fuzzy reasoning. And what is a fuzzy? We basically talk about, or the fuzziness we talk about in the in the AI. So the term fuzzy to refers here, the next term we need to talk about, the term fuzzy refers to the things that are not clear or not understood. And in the real world, many times we encounter a situation when we cannot determine whether the state is true or a false. So their fuzzy logic provides very valuable flexibility for the reasoning. In this way, we consider the inaccuracy and the uncertainties of any situation. So here in the another reasoning, we will talk about the fuzzy reasoning, or the reasoning in under the reasoning under uncertainty. We will talk about the fuzzy reasoning. What is the fuzzy logic? The fuzzy logic is the form of many valued logic. Again, we are talking about the many valued logic in which the truth value of a variable may be any real number between 0 and 1. Or here we are talking about the possibility of a conditional possibility or the conditional probability also. We have talked about the conditional probability in the last lecture. Instead of just the traditional values of a true and false, it is used to deal with imprecise or the uncertain information, and it is a mathematical method for representing the vagaries and the uncertainty in the decision making, where we are talking about the how much it is true and how much it is false, or the possibility or the conditional probability here. So the fuzzy logic is based on the idea that in many cases, the concept of a true or the false is too restrictive, and there are many shades of a gray in between, and it allows for the partial truth, where a statement can be partially true or false rather than fully true or false. This we have talked about when we have talked about the number of reasonings, or the number of reasoning or the types of a reasoning, right? So fuzzy logic is used in a wide range of application. What application here we are talking about? The control systems, or the image processing, or the natural language processing, or the medical diagnosis and the artificial intelligence. Now, what the fundamental of a fuzzy logic is? The membership function. What membership function we are talking about? Which defines the degree of a membership of an input value to a certain set or a category. The membership function is a mapping from an input value to a membership degree between 0 and 1, where 0 represent non-membership and 1 represent a fully membership here. So what concept here we are talking about? What fundamental concept in a fuzzy logic we are talking about? The membership function, which basically depends on the input value to certain set or a category. And when we are saying that the membership function is a mapping from an input value to a membership degree between 0 and 1, not exactly the 0 and the 1, or not exactly the true and the false. So when we are talking about a fuzzy logic, we are talking about the fuzzy rules. What are the rules are here? It is implemented using the fuzzy rules, which are if-then statements that express the relationship between the input variables and the output variables in a fuzzy way. The output of a fuzzy logic system is a fuzzy set, which is a set of a membership degree for each possible outcome or the output value. So in summary, we are talking about that the fuzzy logical is a mathematical method for representing the uncertainty in the decision making. It allows for the partial truth, and it is used in the wide range of application, and it is based on the concept of a membership function, and the implementation is done using a fuzzy rules here. So when we are talking about a Boolean system truth table, we talk about the 0 or the 1, whether it will be a true or whether it will be a false. So in a Boolean system, the truth value 1.00 represent the absolute truth value, and the 0.00 represent the absolute false value. But in the fuzzy system, there is no logic for the absolute truth and the absolute false value. But in the fuzzy logic, there is an intermediate value to present, which is partially true or the partially false here. So here we are talking about the example here. When we are talking about any surface here, whether or the any drink here, whether is it cold or is it a cold. So first, when we are talking about the Boolean logic here, so it's a yes or no simply in a Boolean logic. where yes represent the one, which is the fully absolute truth value, and no represent as a zero, which is fully absolute false value. And in the fuzzy logic, you can see here, but it can be a very much also, very little also, or very less also. So when we are talking about a very much, that means 0.9. When we are talking about a little, it is 0.25, and very less is 0.1. About is it old? So number of outcomes about the input value can be there. So what is the architecture? How the fuzzy logic depends on what type of a four parts, or the architecture here contains the four parts. First is the rule base, then the fuzzification, then the inference engine, then the defuzzification. So what is a rule base? It contains the set of a rules. It contains the set of rules and if-then conditions provided by the experts to govern the decision-making systems. On the basis of a linguistic information, the recent development in the fuzzy theory offer several effective methods for the design and the turning of a fuzzy controllers. That's why the most important application here we are talking about the fuzzy control systems. Most of these developments reduce the number of fuzzy rules here. Or simply when we are talking about the rules that it follows, it contains the set of rules that are the if-then conditions. Then we are talking about the fuzzification. It is used to convert the inputs, right? We are talking about converting the input here. Convert the inputs, that is the crisp numbers to into the fuzzy sets, and the crisp input are basically the exact input measured by the sensors and passed into the control system for processing such as the temperature, pressures, RPMs, etc. So here to converting the input for or preparing an input for the processing here. Then the inference engine. It determines the matching degree of a current fuzzy input with respect to each rule and decides which rule are to be fired according to the input field. So now it takes the decision of what need to be done, or what do you understand by the inference engine, what need to be done with this input, or to get the another value here. So it determines the matching degree of a current fuzzy input, whatever the input has been converted with respect to each value, and then decide which rules are to be fired according to the input field here. Next, the fire rules are combined to form the control actions, or simply here we are talking about it has been used for the decision making. Then defuzzification, it is used to convert the fuzzy sets obtained by the inference engine into a crisp value. There are several defuzzification methods available, and the best one suited is used with a specific expert system and to reduce the error, so that the another value can be added in a knowledge base here. So here we can take up our architecture of a fuzzy logic architecture. What the fuzzifier takes the input based on the rules. It can be passed to the inference engine, right, by the rule based or with the if statements, and the defuzzifier will gives the output in term of a increasing the knowledge base. So membership function is a graph that defines how each point in the input space is mapped to the membership value between 0 and 1. So it describes the how input space is often referred to as a universe of a discourse or the universal set which contain all the possible events of a concern in each particular application. So what are there are three types of a fuzzifiers: singleton, Gaussian, and the trapezoidal fuzzifier here. So what is a fuzzy control? We have talked about it is technique to embody human-like thinkings into a control system. It may not be designed to give accurate reasoning, but it is designed to give acceptable reasoning. It can emulate human deductive thinking, that is the process people use to infer conclusions from what they know. Any uncertainty can be easily dealt with the help of a fuzzy logic. Right? अगर ये ऐसा होगा तो ये हो सकता है, right? So here we are talking about number type of a falsifiers. What do you understand by the singleton, Gaussian, or the trapezoidal or a triangular falsifier based on a one condition or a one input, right? So what do you understand by the singleton? कैसे define करेंगे singleton falsifier को? So any one type of a member, when we are talking about one type of a membership function, we are talking about the any type of a or any one type of a membership function. We are talking about here the singleton falsifier here. And when we are talking about the number of if then rules, then we are talking about the triangular falsifier. So what are the advantages here we are talking about, and in detail also we will talk about what basically a fuzzy system under the uncertainty do for AI. So advantage is that the system can work with any type of inputs, whether it is imprecise, distorted, or a noisy input information, or the construction of a fuzzy logic system is easy and understandable. Fuzzy logic comes with the mathematical concepts of a set theory and the reasoning of what is or that is quite simple here, right? So it provides a very efficient solution to the complex problems because here we are talking about number of inputs or the any type of inputs in all fields of our life as it resembles human reasoning and the decision making because it works on the if else rules and it works on the rule based system and on the membership function. That's why it resembles human reasoning and the decision making. The algorithm can be described with little data also, so little memory is required. We don't need a much memory for it. And when we are talking about the disadvantage of a fuzzy logic, many researchers proposed different ways to solve a given problem through the fuzzy logic, which leads to the ambiguity, right? So when we are talking about the approach here, the approach is not systematic to solve a given problem through a fuzzy logic. So because it can be based on a number of inputs or the imprecise knowledge. So there is no systematic approach to solve a given problem through a fuzzy logic. And proof of its characteristics is difficult or impossible in most cases because every time we do not get a mathematical description of our approach. So as a fuzzy logic work on precise as well as an imprecise data. So most of the time accuracy is compromised or most of the time the accuracy is compromised. What is the application here? And where we are talking about the fuzzy logic, it is used in the aerospace field for the altitude control of a spacecraft in the satellites. It is used in the automated system for the speed control and the traffic control. It is also used in the decision-making support systems and the personal evaluation in the large company business. And when we are talking about a particular artificial intelligence system for a particular industry or a business, then that for that we need the system that can use for the decision making support system as a decision making system. We can talk about the fuzzy logic systems and it has the applications in the chemical industry for controlling the pH, drying, chemical distillation process also. And fuzzy logic here in the artificial intelligence we are talking about is used in the natural language processing and various intensive application in the AI, and we used modern control system as such as the expert system or fuzzy logic is extensively used in the modern control system such as the expert system here. Or when we are talking about a fuzzy logic is used in the neural networks as it mimics how a person would make the decisions only much faster, and this is done by aggregation of a data because it works on the generalization and changing it into a more meaningful data by forming the partial truth as a fuzzy sense. So because it works on the exact possibility of our outcome, that's why here we are talking about the partial truth. So what here we are talking about? So what are the fundamentals of a fuzzy logic? Who has introduced this? The fuzzy logic was introduced by the Lotfi-Jad in the 1965, and it is a mathematical framework for dealing with the uncertainty and the imprecision. Unlike the traditional binary logic, where we just talk about the 0, 1, and which classify the statement as either true or false, but in a fuzzy logic, we allow for the degree of a truth, enabling more flexible and the human-like reasoning, as we have just talked about this. So, in a what we have just discussed, we have discussed that the traditional binary logic operates on the principle of a just 0 and 1, but in contrast, the fuzzy value permits value between 0 and 1, representing a partial truth value, and this graduation allow for more precise or the more accurate decision making and better understanding or handling of a real world problems or the complexities where the binary distinctions are often insufficient. And when we have talked about the in the AI, then we talk about the fuzzy sets, the membership function, where what are the characteristics or the components of a fuzzy logic, the fuzzy sets, the membership functions, and the linguistic variables here. What we have talked about in the fuzzy set, that is a set of a collection of the elements with a varying degree of a membership, and each element has a membership value between 0 and 1, indicating its degree of belonging to the set. And this we have talked in the tensor chapter theory also. What is the membership function? These functions define how each element in the fuzzy set is mapped to a membership function, or the if then statements, whether it's a singular or a triangular or the trapezoidal, right? Then we are talking about the linguistic variables, or these are the variables described in the natural language, such as a high, medium, or low, and they are using a fuzzy logic to facilitate the human-like reasoning and the communication. So what we in the diagram also we have talked about the four process or the components of a fuzzy logic system, where we have talked about the fuzzifications, or the inference engine, the rule based, and the defuzzification. The what is the fuzzification? The process of converting the twist value into fuzzy values using a membership function, and this translates the real world data into form. This we have talked. This also we have talked about the rule based also, the collection of a if then rules, and the desimplification, and also the process of converting the fuzzy output back into a crisp value or increasing a knowledge base we have just discussed. Then we are integrating a fuzzy logic with the machine learning. How we can integrate, or when we are talking about a machine learning, simply we are talking about the AI, right? So integrating a fuzzy logic with a machine learning offers several benefits for managing the uncertainty, or simply here we are talking about how to manage the uncertainty when we are talking about a fuzzy logic. So what it gives? It gives the improved handling of uncertainty, enhanced interpretability, and flexibility, and the adaptability. So what it gives in terms of improved handling of uncertainty, the fuzzy logic provides a robust framework for dealing with imprecise and the which information, enabling models to handle the uncertainty. Then enhance interpretability. The fuzzy logic systems are inherently interpretable due to their use of a linguistic variables and the rule-based reasoning, making it easier to understand and truth or the trust model decisions here. Then the adaptability and the flexibility. The flexibility of a fuzzy logic allow for the creation of adaptable systems that can adjust to changing conditions or the data and the data distribution without extensive retraining here. So it works, or it helps in the machine learning when there is a every time when we are talking about adding a new data, and how to use that new data can be achieved by a fuzzy logic. So techniques for integrating fuzzy logic with the machine learning models. What techniques here we are talking about? Several techniques can be employed to integrate a fuzzy logic with the machine learning models to leverage the strength of both approaches. First, here we are talking about the fuzzy inference system. Or these systems use fuzzy logic to make inferences based on the input data. Right? What is inferences? Or here we are talking about to use the fuzzy logic to make the inference engine. क्या डिस्कस किया हुआ है हमने inference engine में? और what do you understand by the inference engine in AI? कोई बताएगा? What is the inference engine? To use a component, or it is a component to apply the logical rules to a knowledge base that is already present to deduce a new information from a knowledge base and make the decision, essentially simulating a human reasoning here. So it works, or it uses a knowledge base, or whatever the knowledge or the data has been there in the machine. It uses the knowledge base or the collection of facts and the rules to make the deductions and to reach to the conclusions from that data or from that big data. So fuzzy inference engine or the systems here we are talking about, it works on the based on the input data. They consist of a rule base, the inference engine, the method for fuzzification or the defuzzification, what methods it will use. So fuzzy inference engine integrates the fuzzy logic into machine learning models to enhance the decision-making capabilities. And the component here we talk about the fuzzification to convert the input value into the fuzzy value using the predefined membership function, and then the inference engine to apply a set of a fuzzy rules to a fuzzy input to drive a fuzzy output. Then the rule-based contain the number of if-then rules that we can use or that the system can use to define the relationship between the input and the output variables. Then fuzzification to convert the outputs back into a values to produce actionable results. So how? Now this is the inference engine. With the help of a defuzzification, it converts the knowledge or it converts the data presented in a knowledge base or deduce or get the conclusion from the knowledge base after defuzzification. So by incorporating a fuzzy inference systems, machine learning models can handle the uncertainty more efficiently, making more reliable and interpretable predictions here. Now we are talking about fuzzy clustering. Another approach here we are talking about to dealing with the uncertainty under AI or the reasoning under uncertainty. Here we are talking about the fuzzy clustering. What do you understand by this? Unlike the traditional clustering method that assign each data point to a single cluster, the fuzzy clustering allow data points to belong to multiple clusters with varying degree of a membership. Or simply, the most commonly used fuzzy clustering algorithm is fuzzy C means here. Which depends on the which varies according to a degree of a membership. So the membership calculation is the important factor when we are talking about the fuzzy clustering. So what are the key steps in the fuzzy clustering? First, there should be an initialization. We need to define the number of a cluster data present and initialize the cluster centers. Then the membership calculation and assign the membership value to the each data input for each cluster, indicating the degree of a belonging. Then the cluster center update, which recalculate the cluster centers based on weighted average of the data points membership. And then the iterations, definitely when we are talking about the rule based or the recalculations of a cluster center based on the weighted average of a data points and membership, iterations we are talking about or the incremental we are talking about. So iteration repeat the membership calculation and then update or recalculate the cluster centers and update the cluster center until the convergence is there. So fuzzy clustering क्या कर रहा है is a particular useful in situation where we were talking about the fuzzy clustering, which is particularly useful in situations where the data points exhibit overlapping. right? And we need to understand according to a calculation of a membership functions of a where the data points exhibit overlapping characteristics, providing a more enhanced understanding of a data structure. So that's why here we are talking about calculating a membership function so that we can decide from to which data it is belongs. Then we are talking about the fuzzy rule-based systems. The fuzzy rule-based system integrate the fuzzy logic rules into a machine learning models to enhance the decision-making process by the components, the rule extraction, the rule evaluation, and the refinement, which is the most important here. The rule-based is the component of a fuzzy logic here. The rule extraction extract the rules from a data or the expert knowledge that capture the relationship between the input and the output variables. Then we need to evaluate or the machine need to evaluate the rule by applying the rules to the input data into data input data to infer the fuzzy outputs or to get a new data from the extract existing data. Then the rule refinement, continuously refining the rule based on a new data and feedback to improve a system's performance. So what it provides us, it provides the interpretability or the flexibility or the robustness, right? So when we are talking about the rule-based systems, offer us several advantages like the interpretability, that the rules are easy to understand and interpret. When we are need to understand the data, the rules are easy to understand and interpret, making the system decision transparent or the decision making has been understood properly. Then the flexibility, the system can adapt the new data and changing conditions by updating the rule. Then the robustness, the use of a fuzzy rules enhance the system ability to handle the uncertainty and the imprecision. Imprecision.